Okay, I'm going to skip to number 3 on lesson 5.4 and show that one next. So number 3 on lesson 5.4, compute the probability of x successes using the binomial formula. So we're going to use this formula over here. X is the number of successes. So number 3a, n equals 6, x equals 3, p equals 0.03. I'll make up a problem to explain what you might be doing here. Let's say that 3% of all West Delaware students have gone to a NASCAR race. And I want to know that if I go up and ask 6 people out in the hallway, hey, you ever been to a NASCAR race? That exactly 3 of them will say yes. So I'm trying to find the probability that 3 will say yes. So what I need to do first is take 6 factorial, n factorial. On the bottom I need to do n minus x, 6 minus 3 factorial, over 3 factorial. And then I do 0.03, that's my p-value, to the, see the formula over here, to the x power, so to the 3rd power. Then I have to find q. So if on probability of success, if only 3% of people have gone to a NASCAR race at West Delaware, if I subtract that from 1, q is 0.97. So this would be 0.97 to the n minus x, so 6 minus 3. Any questions about that? Now, this is just simply the number of combinations, number of ways you can choose 3 out of 6. So you could use your calculator to, you can use the shortcut to do that if you want. All right? There are really 2 ways you can do the first part of the formula. Let me show both ways real quick here. So I could do 6 factorial, so 6 math over to probability, choice 4, divided by, now, 3, really that's 3 factorial, right? You have 6 factorial, that's 3 factorial times 3 factorial. We can do that in our heads, can't we? 3 times 2 times 1, isn't that just 6? 3 times 2 times 1, another 6. So it's 6 times 6. 36, right? So really just divide by 36. You get 20. Then I'm going to take that times 0.03 to the 3rd and times 0.97 to the 6 minus 3 would be 3rd. So times 0.03 to the 3rd times 0.97 to the 3rd. What does that e negative 4 tell us to do? Decimal 4 which way? Right or left? Left. Negative exponent's going to be, that means times 10 to the negative 4. Move your decimal 4 to the left, and you're going to get 0.0049. So about, or 0.0005 actually. So according to this, if my original data is right, if I went up to 6 people in the hallway and said, have you ever been to a NASCAR race? That's the example that I kind of made up to go along with this. It'd be like a 5 out of 10,000 chance that would be true. That exactly 3 of them had been to a NASCAR race. Any questions about that? And I realize the problem in the book doesn't talk about NASCAR. I was just trying to give an example of where this might be used. All right, let's go on to one more here right away. Number 5. Student takes a 20-question true-false exam and guesses on each question. Find the probability of passing if the lowest passing grade is 15 out of 20. So there's 20 questions, so n is 20 on this one. N is the total number of trials. So if there's 20 questions, n is 20. Need at least 15 right to pass. You're trying to figure out the probability of passing, and you're going to guess on every single question. So n equals 20. X is the number of successes. We got to get at least 15 right. So x could be 15, or 16, or 17, or 18, or 19, or 20. If you get any of those right, you're gonna pass the test. Okay. probability of success. If it's true, false, and you guess, what's the probability of success on each question? 50-50 chance, or one half chance, 0.5 chance of being successful, and Q would be your chance of getting it wrong, which would also be 0.5. So what I really have to do here is I have to figure out what's the probability of getting 15 right, plus the probability of getting 16 right, plus 17 right, plus the probability of 18 right, plus the probability of 19 right, plus the probability of 20 right. Wow. That would mean if I used the formula over here, I'd have to do the formula 1, 2, 3, 4, 5, 6 times. Anybody feel like doing that formula 6 times? I doubt it. Okay? So there's another option. There's a table in the back of the book. So we're going to have you open to the back of your book. This table will be photocopied onto the test for you, so you won't have to open your book during the test. But it's in Table B of Appendix C, so you have to find that in the back of your textbook. I need to find my back here. Find my transparency screen. And the actual page, our N is 20. So the actual page number here you're going to use is page 761. So go to page 761. And you'll see this table. And the reason I sent you to that page, because it's a 20 question test. So N is 20, which is right here. If you're trying to get 15 right, X would be 15. On the top are your p-values. The probability of success is 0.5. So you come straight across, and you come straight down. What are the chances that you're going to guess 15 out of 20 correct on a multiple choice or on a true-false test? What's that say right there? 0.015. So you only have about a 0.015 or 15 out of 1,000 chance that you're going to guess 15 right out of 20. So I wouldn't recommend it. I wouldn't recommend guessing. 16 right. Well, then you just come across from 16, which is right below that. So what's that probability going to be? 0.005. I realize it's hard to see up here, but hopefully you're looking in your textbook. 0.005. The one right below that is the probability of getting 17 right out of 20, which is 0.001. So you got a 1 out of 1,000 chance you could guess 17 right out of 20. Then there's nothing. There's no numbers here. Why do you think there's any numbers here? Well, you can't have negative probabilities, but they're so close to 0 that basically the chances of you guessing 18, 19, or 20 right out of 20 are so close to 0, you just round it to 0. Very, very unlikely. Yeah, I know it's not impossible, but very unlikely. So really what you do is just add up these 3 numbers, which comes out to 0.021. And that's your probability of passing the test. Any questions? Look at these p-values. Notice most of them are rounded to the nearest 10. So you might say, why can't I just use the formula all the time? Or why can't I just use the table all the time? Well, because if your p isn't listed up here, then there's no way you can use this table. Then you have to use the formula.